Computer. All right, folks, welcome to week 5, day 1 of Hotel Platoon. Also, can you guys hear me okay, or is it coming through a little quiet?
Sounds good.
Okay, awesome. So, yeah, today we're going to be talking a little bit more about classes. So we're going to start off with just a tiny little bit of review. So, does anyone remember what inheritance is?
It's taking attributes from a base class and putting it into subclasses.
Okay, let's do subclasses. Um, and just a little bit, one step further, should have asked first. What exactly is a class? In your
Is it
own
a,
words.
I keep hearing that it's considered a blueprint.
Okay, what does that mean to you?
It kind of holds a series of instructions, doesn't necessarily have any type of arguments. It just kind of holds information.
Okay, hold information. That's a good start. Uh, Nicole, Cisco, you guys want to add to that or offer something different?
Um, it's a template that you can use to create objects with.
Okay. I'm gonna extend that a little bit and say you want to use it as a template for objects with similar properties. So in general, like you don't, well, you might have a case where you want to do this, but 80% of the time, you probably don't want to create a class that you use to describe an apple and then use the exact same class to describe a horse. Like that's not really a good idea. But you can use a class to describe, let's say, a Gala apple versus a Fuji apple or something like that. So let's go back to the holds information part that Art brought up. What goes inside of a class? There's two words I'm looking for.
Um,
And attributes.
Attributes is one of them. What's the other one?
Instance,
Really close. The other type of thing that you can put into class besides attributes.
Methods.
Methods. Perfect. So attributes are going to be your variables. Methods going to be your functions. One type of method is an instance method. So Art, since you brought up the word instance, what does an instance method do?
it allows you to run something simply within that class.
Okay, yeah, it's a good example. I guess let me correct myself. I was thinking less so of an instance method and more of an init method. But you are correct. So what is an init method, if you guys remember? And what does that allow us to do?
It initializes the attributes you want to use in the class.
For the class instance. Yes. So it doesn't initialize the same attributes for all classes or for all objects of that class, but just for the specific instance that you have, right? So this is where that distinction in our attributes comes in between your class variables and your instance variables, right? So class variables, let's do the example of a car, right? A class variable for a car could be something like is car equals true, because that's true for all of the objects of type car. An instance variable might be something like license plate, because a license plate is going to be, yes, a license plate is going to be different for every single instance of that car class. So we've got your init method. There's other methods that we will talk about later that you don't need to know. But this is the main idea of what goes into a class. So now that's out of the way, let's go back to talking about inheritance very briefly. So I think Adam mentioned that inheritance is a process by which you have a base class whose attributes then get disseminated to subclasses. Another way we can think about this is a parent-child relationship, right? So you'll have like a parent class and that sends attributes down to a child class. Let's see. Let's do an example. So let's say I have a class called employee, and this class is going to have a couple of attributes. You could say like name. We'll have right here, let's do a def init, and we'll take in name, ID, and job. And we'll say, let's see, so let's say name is name, ID is ID, and job is job. Would this work?
No,
Why not?
because I think the definite requires that you have a self in there.
Yes. So you have to have the self, and now I need to do self.name, self.id, and self.job. I'm gonna change it to a lowercase id, just so that it's not freaking out on me a little bit. Okay, perfect. So this is my employee class. Now, are these class or instance attributes?
Instance.
Instance, perfect. Okay, so, oh, okay, I think I hit something. Exit. There we go. Okay, so now let's say that I wanted to define a manager class where the job of the manager is always going to be manager. How do I do this? I want to take in name and ID, but do I really want to go and make that definite all over again? No. How can I inherit from employee to make my manager?
Place parentheses at the manager and put employee inside of it.
Okay.
And then you go below job variable, and you make another line under job variable and do a definite, and yep, well, yeah.
Oh, well, I was
yeah,
hoping it would only autofill the init part, but okay.
right.
We'll pretend that didn't happen and Cisco said the whole thing. Well, since you were answering though, I'll do one more question for you. What does super do?
Super takes the super takes the forget what you called that. It takes the init function at the top, and it basically inherits all of that information you have at the top. So from the employee parent class.
Perfect. Yep. So super basically just says, hey, whatever thing I'm going to put after that dot is going to come from my parent class. In this case, it's the init method. You can do a super for a variable, a super for another method too. Totally fine. So, all right. So this is the example of inheritance. So again, it's sort of passing parameters down from one class to another, creating spin-offs, if you will. Now, let's say that I have an employee and a manager, and they both work at a store. So I'm going to have a store class, and I want to, let's do a break. Okay, well, that's not pass. There we go. So let's say inside my store class, they'll say my store must have, let's see, a name, an address, a manager, and employee. So how do we do this? Well, the first thing that comes to mind is using the tools we just came up with for inheritance, right? So you have attributes going from a parent to a child. Is there a way that we can use inheritance to help us do this for a store? Okay, I'm seeing a couple of nods. Cisco, you just went. So Nicole, talk to me. How can we use inheritance for this?
The same way that you put well, I guess technically you wouldn't have to do employee there, but you could put manager in the parentheses next to store.
Okay, so let's think about it. So what would putting manager in here, what would that do for us?
It would inherit the manager attributes. So you would be able to find the manager in there.
So if it inherits the manager attributes, is that necessarily what we want to happen?
Yes, no.
Well, why not?
Because it still needs its own name and address. You just want to bring in the manager and the employee.
Exactly. Yep. So here, let's make it a little bit simpler. What if instead I said it needs to have a manager ID and an employee ID? So forgetting about the previous two classes. In that case, we could basically do the same thing that we did in our init method before, right? And we're just, so pretend that we ignore all the other classes we made up there. And we'll just make this like store name. We'll say store address, manager ID, employee ID, and now starts the fun journey of copy pasting all these variable names that I made a little bit too long. So manager ID and then self dot employee ID. Does that part make sense? Like if we're just doing it, out of the blue. So now let's go from this back to what we already had before, where instead we're going to have a manager and an employee. So at its fundamental level, what is a class? We talked about it a little bit up at, well, we didn't talk about it at the top. But at its most basic, a class is an object. What are other things that are objects? Integers are objects, right? Floats are objects. Strings are objects. Lists are objects. And class instances are also objects. So, if I can take in this manager ID, which is an integer, probably, which is an object, what is stopping me from saying, I'm not going to take in manager ID. I'm going to take in an instance of the manager class. And for employee, well, what if I just, instead of just taking in their ID, what if I just took in an instance of the employee class? What do we think? Could that work? Or does it seem spurious?
I think it could work.
Okay. Anyone else care to share their ideas?
I believe it would work, but I think that you don't want it to have it set up like this for larger files. Just reading today's curriculum, I think that we have to distinguish when we have an apple versus an apple tree, because you can have various kinds of apples and you can have various kinds of trees, but you don't want to be inheriting in the apple class from the the tree. So in this place, we have employees, we have managers, but we don't want to inherit from store.
So are we inheriting in this case? Oh,
Right
can't
now you're
hear you,
not.
right?
Yeah, right now you're not because you're not calling it in. It's like you're just duplicating.
Right. Or more specifically, this kind of goes back to what Nicole was talking about earlier. We aren't taking any characteristics of manager or characteristics of employee and dropping them into store. We are taking an entire manager and putting them in store. So what's an example? So what we could say is let's say we have manager art is going to be a new manager, and your name is going to be Art, your ID is going to be that number. Then similarly, let's say that we're going to have employee Nicole is going to be a new employee whose name is Nicole. You will have a different ID that is totally not me mashing my keyboard, and your job will be all the jobs. So we now have a manager and we have an employee. So now what I'm trying to demonstrate is I want to show that at my store, whatever store I end up creating, that both Art and Nicole work at my store. So the way we could have done that before, right, is we, again, like I said, we could have that manager ID, employee ID, go back and put the IDs back in. And we said that was fine. If we have these as IDs, we're totally good and hunky-dory. Right? So we could say something like, Omer's store is going to be a new store. I call it my store. Its address is going to be something, something. It's very original, I know. And then the manager ID is going to be Art's ID. So let's copy paste that. And then the employee ID is going to be Nicole's ID. Now that's completely fine, right? Anyone have questions or concerns about this formulation of my store as a class instance? So the point I'm trying to make is, again, this is an object, that's an object. This part is an object. I could just as easily, let's delete the IDs from here. So that way we're not misrepresenting what we're doing. Remove the ID and manager. We could just as easily go and substitute manager Art and employee Nicole into there. So now, if we look at my store, it has the same name and address. But if I want to look at the store manager now references Art, the manager, not Art's ID, but it references Art as the manager class. So we can see an example of this, right? So let's print out my store.manager. So what do we expect to happen? Anyone have ideas? What do we expect to happen when I print out over store.manager? What should it return? What should it give us?
It's going to return my store 12141 something something. Then it's going to show manager Art as an object and employee Nicole as an object.
So let's try it.
It's going to show the address of those two. Yeah, that's what I think.
Okay, let's see what happens. No. So let's break it down. What gets returned to us? Forget the main part. So it returns a manager object, which is exactly what it so said, and it gives us the memory address. So what does this mean? What is this manager object that we're getting back? I mean, in theory, we're getting back manager Art, right? But there's a very easy way to verify that. Let's say I want to get the name of the store manager. How can I change this print statement to give me the name of the store manager? What do I need to add? So again, this thing is just a stand-in for a manager object. So if I gave you a random instance of the manager class, how do I get the name attached to it?
You have to add dot name at the end.
Dot name, exactly. So to get, so this thing, this print statement returns a manager, right? So we could say owner's store, we can say store manager is that, right? Just to keep it simple. And then we're going to print this out. So if I want to get, so the name of store manager, what would I have to do? Sort of like Adam said, store manager dot name, right? Because again, store manager, we just established that is an object of type manager. And in order to get the name of a manager object, we just have to access the instance variable. And let's just print that out. So if we run this, first thing we see is, again, we get that manager object. So we see that, again, the manager attribute is a manager class instance. And then the name attached to that class instance is art, which is the same name right in here. So what we've effectively done is we've set up this store. So we'll say, like, you know, so this store instance is going to be my store with address thing. And then we're going to say that the manager is going to equal manager class instance. And then the employee.
Yeah, I was trying to say, hey.
Does that make sense? Kind of. Okay. So, all right. Let's try another one. So here we've gotten Art's name. Let's say instead I want to get Nicole's job. Or sorry, I want to find the job of the employee at the store or at my store. What is the code I need to do to get the job of the employee at my store?
Store employee dot job.
So we could do store employee dot job. So is that what you're saying, Nicole?
Yeah.
But
Or
we don't have store employee defined.
so we'd have to make store employee equals Umar store dot employee.
Okay. What if I told you we can combine these into one line? So what am I doing here? What I'm essentially saying is we're starting out with the store object, right? So we're starting out at the highest level. I'm then going into the dot employee. And dot employee is going to pull out, what's it going to pull out? It's going to pull out an instance of the employee class. And then inside that instance of the employee class, which is up here, I'm going to go and pull out the job. So we're going from one class to another class that is subsumed within it. And then in that second class that's combined, we're then going to get out its attribute. And we can print this out just to make sure it returns what we expect. We see that indeed it returns all the jobs, which is what we specified is Nicole's job. This is a way that we reference classes within other classes like that. Does that make sense to everyone?
I'm kind of hesitant, but this might be a dumb question. But Why do we have to access store first? Why can't we just go directly to the employee class and print it from there?
Well, let's pretend that here, let's do something a little bit yucky. So we're going to replace this nice variable of employee Nicole with the employee object. So again, this and that are the same thing, right? We're all in agreement on that. So hypothetically, where I see employee Nicole, I can just copy paste the actual definition, and it should be the same thing. We're going to do the exact same thing with art. And we're going to comment these two out. So if we define my store in this way, the only thing I have is my store. I don't have direct access to the manager. I don't have direct access to the employee. So how can I use the employee class to figure out the employee's job if I'm not given an employee class object or class instance? You can't. So you have to start from what you're given, which is the store, the highest level object. Does that make sense?
Yes.
So here, I'll just write it in right here as well, just to make it a little bit more obvious. ID, and then we have job. Nope. So it's sort of like, again, you're going from the highest level possible, right? So you're starting out with the store. Then we're going into either manager or employee, and then from there we're going one level deeper. It's kind of like in like a folder tree on your computer, you can create like one folder that has like two subfolders, and then another two subfolders, and then files and subfolders. That's kind of like what composition is. And you can kind of see that, how this looks a little bit like that, like a hierarchy. That's what class composition is. It's basically stacking things within other things. Inheritance, on the other hand, is creating spin-offs. So inheritance is, or like, again, creating like a generic apple class, and then you're creating another class for gala apples or for red delicious or something like that. So they have functionally different uses. So let's run through a few examples of this. So we're going to play a little game now. We're going to call this composition or inheritance. So I'm going to give you guys a bunch of examples that I am going to come up with, hopefully on the fly. And I want you guys to tell me, if I give you these two classes, are you going to relate them using composition or inheritance based on what we just talked about? Sound good? Okay, so I'm going to call on people. Let's see. Now I need to find an example. Okay, here we go. Nicole, your two classes are going to be let's see, like drink and water. Like a bottle like of soda or like a generic drink, and then a bottle of water. Are these two classes related with composition or inheritance?
I'll just go with inheritance.
Why?
Because you can use the attributes of water to make the other drink.
Good. Yep. So water is a type of drink. So because of that, I mean, hopefully. So because of that, whenever you have them that say A is a type of B, that is generally a case where you want to use inheritance. With class composition, on the other hand, it's more like A has B. So, well, let's do another example, sort of based on. Let's see. Cisco. Okay, let's say your classes are going to be chair and cushion. Okay, so I'm sitting on a chair that has cushion. Is that going to be an example of inheritance or composition?
Composition,
Why composition?
because the chair has the cushion.
Perfect. And a cushion is not a type of chair. No, that would probably be a comfortable chair, but not in this case. All right. Art. Let's see. A room and desks, plural. Is that inheritance or composition?
Composition.
Okay. Let me ask you a follow-up question. In the example that we just did above, I'm only taking in one manager and one employee, right?
Yes.
Now, I just mentioned that the room has multiple desks. That's a similar question to saying my store has multiple employees. How can I put multiple employees in my store? Do I want to do something like self.employee1 is employee 1, self.employee2 is employee 2, and keep going? Or is that a really bad idea?
That's a bad idea because if you within your class of employee, you can I believe you can create individual employees.
Okay. Yep. So what's an easy way for us to resolve this? And this is a free ball to everyone in the room.
Make him make the employee parameter list.
Okay. So let's call it employees. And now this is going to be a list of our employees. So let's remove that and let's add in an employee of Cisco, and we'll do that, and we'll say some of the jobs. So Nicole has more responsibility. So now I want to say that both Nicole and Cisco are employees at my store. How can I specify that?
By placing square brackets around the employee part, and
Okay.
then just dropping. You can for this you just put employee Nicole and employee Cisco.
Perfect. So really quick now, let's look at the list of all of the employees. So we're gonna comment out this little part, and we're just gonna look at what employees gives us. Before I run the code, what do we expect? What do we expect this, and forget the below, what do we expect the dot employees to print out for us? Not Cisco, because you already answered. Nicole, any ideas?
It's gonna print out the object.
Which object?
Hmm? The employee Nicole and the employee Cisco in a list. Because it's not
That's what I was looking
referencing
for.
an attribute.
Yes, so it should print out a list of both objects, which it does. We see it prints out 2 employees in that list. So let's say that I wanted to get Cisco's job. There's Cisco's ID this time. How can I get Cisco's ID from this list? So, well, let's start here. Which of these employees is Cisco?
Yeah, you can do square bracket 0.ID.
So that would work, except that Nicole is the first employee.
Oh, I'm sorry. Yeah,
So technically,
0,
we have to
1.
do employees 1.
Yeah.
And again, we see that because in employees 1, this will give you a list. This will give you the index. This will give you the thing at index 1 of the list employees, right? Which gives us this guy. And then we hit .id, and we get this ID number, which is Cisco's ID. So now we've changed our little store instance to be now employees is a list of employee class instances. And then each of those employee class instance has a name, ID, and a job. So we've added one more layer, if you will, to that hierarchy. Does that make sense? Okay. Let's do a couple more practices of this composition or inheritance, and then we'll stop the questions. Let's see. Oh, Cisco. An Apple store and its inventory. Is that inheritance or composition?
That's inheritance.
Okay. Why would that be inheritance?
Because you can have several different Apple stores, right? And each Apple store is going to have different different types of inventory or numbers of inventory inside each store.
Okay. That's a fair point. Not exactly how I was thinking about it, but that's a fair point.
Uh-huh.
I'll concede.
Yeah.
So Nicole, let me flip this over and be a little more specific. An Apple store and a laptop. Or an Apple store can sell many laptops, and it has many laptops in its inventory. Would that be inheritance or composition?
Composition.
Composition. So to add one more layer to that, would you, when you're like designing it, because again, I mentioned that your Apple store can have a ton of laptops, would you probably use the list feature or just take in individual laptops, like one by one?
A list feature.
Perfect. Yep. All right. One or two more. Let's see. Art. Let's see. A window and tinted glass. Is this composition or inheritance?
Inheritance.
Why inheritance?
Because the tinted glass is a type of window.
Okay, that's true. I'll counter that by saying you can put tinted glass has different characteristics from a window. So we're both right. It can be inheritance or it can be composition. Which one it is depends on your user specifications, right? Like, let's say if the only if your user says, yeah, I run a window company and I have like generic windows, but I have ones that are made with like a tint on it. And I just want you to make a class that has, material equals tinted glass versus not. Super clearly an example of inheritance. But let's say that instead, the window class is just meant to be for like a window frame. And the glass itself is meant to be something that's completely different. In that case, it might be composition. So sometimes the answer is really obvious, whether it's one or the other. Other times, it's a little bit up to you and up to the decisions of your client or the program that you're writing to decide which way to go. All right, one last one, and then I promise we'll stop. And this is a free for all. Let's see, a chalkboard and a card. Is this inheritance or composition?
What was the second thing?
A card.
Oh, that's well, that's neither one.
Yeah, it's neither. There's no relation between a chalkboard and a card. Sometimes you don't need to relate every single class to each other. So sometimes neither is a completely acceptable answer. Another thing that you can do is if you're having trouble deciding if it's inheritance or composition or neither, is write class A out completely, write class B out completely on its own, and then say, there's a bunch of similarities between class A and class B. Okay, maybe it's inheritance. They both share like 7 of the same 7 of the same attributes. Or, class A takes in a list of class B. All right, well, that's composition for you. Or these two classes are completely different, dogs and cats, except that they have 4 legs and are furry. But they're completely different. So we don't need to make any sort of linkage between them. Perfectly acceptable answer. All right, that's it for lecture. Any questions about composition or inheritance before I
Okay.
turn you guys loose on problems?
Could you do me a favor and scroll up to the manager class for me, please?
Sure. Up here?
Okay. Yeah, that's good. Um,
I'll send along a copy of the notes after as well, so you guys have them.
okay. I got it. Thanks.
All right, go ahead. Yeah.
Slightly off topic, but the it seems like in so many instances we are getting memory locations as a result, and I'm sure that was deliberate. So my question is, will this memory location ever be important for us?
Yes. Short answer, I'm gonna leave it there. Is it important right now? No. The only thing that is important to note about it is two objects can't live at the same memory location. So if I give you, like, it's like basically a memory location is unique to every object. So the employee Art and employee Nicole cannot live at the same place. That's basically right now the only thing you need to know. There will be later, especially when we get to things like optimization and pointers and other far more advanced topics, and when you jump into other languages that memory becomes a huge deal in, it becomes a lot more important. But for the stage you're at right now, don't worry about it too much.
I have a question.
Go for it.
So you showed us how to do it with like one employee and with like two, but like what happens if you have like 50?
All right. I don't know if I can do 50, but I can
Mhm.
do like 4.
Okay.
So does that work?
Yeah, because I was like looking at the list and it seems a little impractical to like list the actual like names of everybody in there if you have that many employees.
All right. So we now have 4 employees, and Josh is unfortunately unemployed or is going to be unemployed very soon. So we've got 4 people. Again, the option, like I think I meant Art shot down before, is I could say employee 1, employee 2, employee 3, employee 4 up here. No, please don't do that. Easy thing that we can do, and here, let's name these from employee 1, 2, 3, and 4. We can create a list, employee 1, employee 2, employee 3, employee 4. And we can keep expanding that. Now, in reality, you're almost never going to hand import every employee like this. Instead, what you'll probably do, which we will teach you guys how to do in a couple weeks, this looks like it could be an Excel sheet, right? You've got,
Mhm.
3 columns and 4 rows, and you can keep adding rows to that as much as you want. Wouldn't it be great if there was a way that you could take that information from an Excel sheet and turn it into employee objects? Yes, there is. And we will learn that soon enough. You can turn that Excel sheet into a list of employee objects that then has 50 or 100 or 1,000 rows. And then you can take that list and put it right in there.
Okay, cool.
So yeah, hopefully that helps answer the question. Any other questions before we wrap? Okay,